Hello. So my name is David Birkás. I'm a senior manager of user experience, which means I have a beautiful team of 7 UX person. And I also a leader of a 14 people development team. So I'm gonna show some examples like how do we work in healthcare UX design, which can start people in great careers, like our next speaker, who used to work at GE. So, what is healthcare? That's the first question. And healthcare is your smartwatch, right? You run and you get your sleep tracking and stuff like that. We call that healthcare. And then whatever happens in a clinic or a hospital, that's also healthcare. So the doctors and the patients and so on and so on, that's also healthcare. But third part, healthcare is also politics, and there's a secretary of healthcare, and I'm going to talk about the middle one today. So doctors and patients. So the first point here, that it's all about safety, and this is the one above rule in healthcare. It's like everything has to be very, very safe. This is an interior of a Tesla, and there is a 17-inch touchscreen in the middle, which is everyone likes. But every car journalist in the world mentions when there's a touchscreen in the car that please give me like tactile buttons, please, for the air conditioning and stuff like that. There is a reason they are saying that, because if you use this screen, you get distracted for a minute, or not a minute, or for a second or something like that, or maybe a fraction of a second, but you get distracted. And of course, it's manageable. But if you move forward, this is an interventional X-ray machine. So where you get a stroke, even if it's heart or brain, this is where you lay down, and there's an interventional radiologist working on you, saving your life. As you can see, there is a touch screen, but all the rest is a tactile control, because you don't want to have an interventional radiologist get distracted even for a fraction of the second, right? So it's really all about the safety. So our first rule is like do no harm, because the FDA is watching you. Most of the UX person usability testing and all the stuff is, you do it because you want to do it. This is a part of our profession, but in our world, it's not just part of our profession, but it's actually mandatory. So you have to do it, you have to file it, and you have to prove it that you cannot kill a patient with your product. And the other problem is that the patient is just, they are laying on the hospital bed, but your user is the doctor actually. So this is like rule number 1. And I brought some examples about AI, which is everyone really hyped about today, right? So it's like if you see some imaginary product or imaginary design, it's all about AI, right? And I thought like we can have like good examples about this. AI is good to predict in prediction of diseases, and of course it's good in diagnosing diseases, and it's good in treatment, of course. So what do we mean with AI? Of course, I mean like machine learning and deep learning and stuff like that. It is it is a big promise in healthcare, because in these cases, in prediction and diagnosis and treat, we can make healthcare faster. You can treat people in better ways. Or there are situations where this is like 3 proteins. I don't know which kind of proteins, but you have to know that in the pharma world, it's not about like simple molecules anymore. It's really about this one. We expect that cancer will be treated with proteins and biological medicines. But the problem is these are living organisms. So it's not like I pour some chemicals into a big bucket and then I get a good medicine, but I have to grow cells and then crush them and then take out the protein. And those cells can die, and they are like very, very picky about the environment and stuff like that. So again, if you go back to AI, this is not something you can predict the behavior of these proteins on a single computer, right? You need like supercomputers, actually. So AI is a big promise. But with AI, there are ethical and security and accuracy problems, various ones. So let's go with the first one. So there's a smartwatch on your wrist. Many people have a smartwatch on their wrists. So, and you know, an Apple Watch, there's an ECG in it, so it can actually predict that you will have a cardiac arrest. So it can save your life, pretty much. And this is a great thing. But what happens if this guy, it turns out that you know, he's wearing a smartwatch. I don't know if he's wearing a smartwatch or not. But what happens that if he can predict he has a neurodegenerative disease, Alzheimer's or Parkinson's, or he will have a cardiac arrest? What happens if the patient where we can predict these things is not a rich white guy, but a person of color who is poor? What if the insurance company can access your medical data and the AI tells them that you have a high chance to develop a prostate cancer? These are the ethical factors that, you know, especially in the US, if they can predict that you have a high chance to develop a prostate cancer, they will charge you more. That's 100% sure. So that's problem number one. The second part is the self-driving car problem, right? So back to the Tesla. Well, that's what everyone wants, right? With the self-driving car. You don't care about the dashboard because you sit in the back of the car, you just send a text message for your significant other. And of course, there are working solutions, but we're still far from the like a real safe self-driving car. And the thing here is that we have many emerging options with the self-driving cars, right? There is a radar, a lidar, night vision, heat vision cameras, and so on, and so on, and so on. So like there is like many sources where we can collect data. However, if you go for a radiologist, and this is like let's say there is a vision of the future, the roboradiologist, then pretty much they can work on a low-res image with like 512 by 512 pixels or 1000 by 1000, so it's like not a really high resolution image. And of course, these are series of images. Also, like you have a lower chance to get more and more data because you don't want to you don't want to scan the people many ways because there are like dosage. And you know, you don't want to harm them, so it's like there is a limit, there's a cap on how much radiation you can put on a patient. So again, like we work from like much less data, and so this is not a very easy thing to do when we think about like a self-driving radiologist. My second point is, or third point is that there was the racist Twitter bot. I think everyone remembers that. But so every AI is as good as the source data you train them upon, right? So it's like there is no data just there. You need some data sets to train your AI. And that's what happened with Microsoft. So they trained their Twitter bot, and it became like racist right-wing Twitter user. So they had to shut it down. Okay, so in healthcare, we need to train the robo-radiologist of the future with some data. Now, this is how data looks like, right? There are a couple of things here. One is that, a full-body CT can be like huge, and it's like 1.5 gigabytes. So it whenever we start to design products, there's like the first thing, like let's use cloud. But uploading this stuff to the cloud, it takes time. And of course, as many more and more scans you do, there's a lot of time. So you need you need time. So first design issue here that if you need immediate results from an AI algorithm, then you don't have time to upload this data to the cloud because it takes sometimes an hour. Second point here, that we really like to believe, especially in Europe and here in Hungary, that there is this super fast internet. There is it's everywhere. It's a commodity. But actually, if you go to Africa, which is an obvious example, but if you go to Bradford, Ohio, then the maximum internet speed you can get is like 8 megabits per minute, which is slow. So you have a huge data set and the slow internet. So what you do sometimes is the old way, you put like computers into the hospitals, and that's where you can run your stuff. Second thing here, that every person is different, really. There is like, I mean, your fingertips is unique to you, right? Your DNA is unique to you, and your body is really unique to you because we grow differently, we eat a lot, we do drugs and alcohol and stuff like that. So whenever we think about AI in healthcare in general, that it's not easy to say for an algorithm which part of yours is which part. It's like for a radiologist, it's kind of obvious, but for an AI algorithm, it's not easy just say out of the box. So what happens that there are training sets where real radiologists just mark your organs or the patient's organs, and that's how they train medical algorithms. But those data sets are scarce because you can what you can use is like dead people data because they don't care about it anymore. Sorry, and then some other people who consent, but that's a low number. So again, whenever we think about AI and things like around that, and then design like great stuff, maybe it's worth to think about your internet connection speed, your data size, and like how good is your source data. Yeah. So we are getting around the end. So I talked about that, just to reiterate, every person is different. And then don't take the environment granted. Maybe there's no high-speed internet. And don't take the quality of the tools you are using granted, which means like maybe you cannot access the supercomputer power in Amazon in a way. But the most important one is that all of this is question of a responsibility because your user is taking a responsibility. In our case, it's a high responsibility, right? It's like very, very important because they treat people. So the patient's life depending on them. And this is a responsibility for us and for you as well, of course, that, they just channel back that responsibility to you as well because you have to make good products. So as a finish, I say we can aim for like the sentient holographic robot doctor of the future, and of course that's what we can do, and this is a dream of ours. But what I like to say, let's start it with this one. So let's design exoskeletons, because that's what we do. We can design great software which is helping our users to make great work. So that's pretty much all. Thank you.